nice thing is when we're learning these last couple graphs is that we can still use several of the things we learned before. We can use period, we can use amplitude, we can use the idea of the dots that we have for sine and cosine. All right, so let me show you how to use what you've already learned and connect it to the last thing we need to do. Yesterday, we saw that cosecant x is directly connected to those 5 dots of sine. So it uses the 5 sine x dots. That's what we did yesterday. We also did that secant x uses the 5 cosine dots. And then it turns some of those into asymptotes and some of them into branches, and we create the new graph. So tangent and cotangent are similar. They're going to use the dots that we already have. But I want you to think back to what tangent means. Okay, what does sine, yeah, say it again. Tangent means sine over cosine, which means we are going to use both. We're going to use the 5 sine dots over the 5 cosine dots. And we're going to use that to create tangent. So before I show you how to do that, let's review what the 5 sine dots are. So let me just look at my graph here. And my 5 sine dots go like this. These are normal sine with a normal period. Everything about it is normal. Oops. Okay, every 4. 1, 2, 3, 4. Okay. Here are the 5 normal trig dots for sine. Let's list them in order. What's the first one? 0. What's the second one? 1. Third one? 0. Fourth? -1, 0. Okay, I want to make a list of those. Here, those 5 sine dots in order. They went 0, 1, 0, -1, 0. Those are the 5 sine dots. All right, now I want to think about the 5 cosine dots. So I'm going to go back to my graph and I'm just going to think about those. The 5 cosine dots start at 1. So sine of x is the red. Cosine of x is going to be the green. And cosine of x went this way. Okay, those are the 5 dots for cosine, which form a different shaped wave. And so the first cosine dot is what? 1. Okay, second one is? 0. And then, okay, so let's list those in order. The first cosine dot is 1. The second one is 0. The next one is -1, and then 0 and 1. We want to do sine over cosine for every single pair of these dots. So 0 over 1, 1 over 0, 0 over -1, 1 over 0, 0 over 1. We want to think about what that would produce. What kind of new dot would that make? So let's look at 0 over 1. What is 0 divided by 1? It is 0. So 0 is first. Next one, what is 1 divided by 0? It is. Okay, so undefined comes next. Then the third one we're back to is 0 over -1. Well, what is 0 divided by -1? Back to 0 again. Does it matter about the negative when you're dividing it? No. Okay, as long as 0 is in the top, it'll be 0. Fourth combination is -1 over 0. What is that? Undefined. Does the negative matter? No. Because when you divide by 0, then we get undefined. And then the last one, the fifth combination, would be back to 0 again. So we've got 0, undefined, 0, undefined, 0. Those are the 5 pieces of a tangent graph. They are spaced 4 units apart, just like we've done all of the other ones. But how do you graph undefined? Any ideas? You do graph it. The graph of undefined is an asymptote. That's what undefined means. All right, so the graph of undefined is where you're going to put an asymptote. So 2 of them. All right, so let's go to our graph and let's do the pattern. 0 asymptote, 0 asymptote, 0. Those are going to be the 5 things that we draw. So I'm going to clear off this graph. And I am going to create 0, count 4 dots, and make an asymptote. 4 more dots, and make 0. Okay, 4 more, and make an asymptote. And then the 5th one. Okay, those are the 5 pieces. Those 5 pieces you will label the same exact way we've labeled period before. So let's suppose we're working with y equals 2 tan 2x. The period is 2 pi over b, so 2 pi over 2, which is 1 pi. So you can label the 5th position as 1 pi, which means you can label the center as half pi, and you can label your asymptote. The first one is 1/4 pi, and the next one is 3/4 pi. Once you have your 5 important pieces labeled, I would encourage you to draw a few more pieces. So if we went out farther to the right, what would come after that last dot that I've drawn? What would the pattern be next? Another asymptote, so I might as well make another one. And if I went to the left, if I went backwards, what would be created there? Another asymptote, so I might as well follow the pattern of labeling. So if the asymptotes went 1/4 and then 3/4, the next one should be 5/4. And the one on the far left should be -1/4. All right, now we're ready for the amplitude position. Okay, the amplitude is placed in a particular spot. It goes right here. It is between the dot and the asymptote. That's where the amplitude goes. Right exactly halfway. So that would be right here is halfway, and then we go to 2 for our amplitude. So it's going to go, we're going to have an amplitude placed right here at 2. So it is to the right of the origin, but before the asymptote. And then there's another one here, and there's another one here. Okay, that's where the amplitude goes. But just like in sine and cosine, there has to be a -1 also. So the -1 goes below on the other side. Doesn't it look like you can connect those 3 dots really nicely? And you sure can. So go ahead and connect them. Now, can you connect those 3 segment pieces to each other? Why? The asymptote is blocking you. Okay, you cannot just connect them. So what happens is, as you leave the amplitude and you try and get close to the asymptote, it's going to shoot you up to infinity. And as you try and get close to the other asymptote, it's going to shoot you down to infinity. That is what a branch of tangent looks like. The ends of the the ends of each branch go down toward infinity and up toward infinity. Okay, that is the graph of tangent. The domain of tangent is found the exact same way. you're going to just do your asymptotes. So the domain would be written like this. Domain, all real numbers except all real numbers not equal to, and then list me at least 3 asymptotes, if not all of them, but I would maybe say -1/4 pi, +1/4 pi, 3/4 pi, ... to show that it covers all the asymptotes. Now you remember how yesterday we had range of upper and lower range? Okay, we've got ranges of each piece. So let's do the range of the first piece. What's the lowest value of the first piece? -infinity. What's the highest value of the first piece? +infinity. So the range here is going to be -infinity, less than y, less than infinity. No equal to bar. What about the next piece?
You get all the numbers too, right?
Yeah. What about the middle? What about the second branch? What's its range? -infinity to +infinity, right? And what's the next range? Okay, so they all have the same range. So you don't have to worry about listing it. They're all the same. Okay, you don't have to do an upper range, like a range 1 and a range 2 and a range 3. All the ranges are exactly the same. That's also the same thing. Okay, any questions about that so far? Okay, let's try another one. Okay, let's try y equals -tan x over 2. I would just encourage you to get your 5 primary pieces on there right away. Dot followed by asymptote. 4 pieces later, dot followed by asymptote. Finish with a dot. Those are your 5. I would get those on there first and then label. My period will be 2 pi divided by what number? Right. And 2 pi divided by 1/2 is 4 pi. Which means my last dot of the cycle is labeled as 4 pi. Which means the middle one is 2 pi, and all the rest of them. Once you have the 5 primary things labeled, then go ahead and maybe add a couple more asymptotes to the pattern and label them too. So there would be an asymptote on the end, and the left and the right end, and those would be labeled according to the next pattern. So 5 pi and -1 pi. So then you can say your domain. And your domain is going to be all real numbers except the value of all the asymptotes. So list me at least 3, -1 pi, +1 pi, 3 pi, etc. Okay, what's my amplitude? Amplitude is never negative. The amplitude is 1. What does the negative do? Not inverse. Reflection. Okay, the negative makes it a reflection. And so my amplitude is 1. So that means the high number is still 1, but it's flipped the other direction. And so I can get those 3 pieces. So it looks like I've got 3 dots. And then we'll connect those 3. And we'll head down to infinity without crossing the asymptote. Head down to infinity without crossing the asymptote. And head down to infinity. So the range is still -infinity to +infinity for all the pieces. Okay, any questions so far? Do you see how memorizing the original 5 for sine and cosine were important? Because they build the other ones. All right, so let's build cotangent now. So I'm going to go back up to the top of my notes where I was working on that, and we're going to build cotangent in the same way. So cotangent of x is cosine of x divided by the sine of x. So it's going to be those 5 dots of cosine, which are 1, then 0, then -1, then back to 0 and 1. Those are the 5 cosine dots. And then the 5 sine dots. So 0, 1, 0, -1, 0. And then divide each of those. So once we have the 5 on the top divided by the 5 on the bottom, what will be the first part of the cycle for cotangent? An asymptote is first. And then, so our first 1 over 0 is an asymptote. Then after the asymptote, we have our first 0. And then we have another asymptote. And then we're back to 0. And we finish with an asymptote. So the major difference in tangent, one of the differences between tangent and cotangent, is what you start with. So just look and compare what we're starting with here. Come on. There we go. We've got 0 compared to asymptote. Okay, the way those two things start. The rhythm of the cycle starts differently. So if you get off, that's going to mess you up. So make sure you start with the right thing. All right, so let's go down. Should have one graph left. Give myself a little room here to work. Okay, and for this one with you guys, I'd like to do y equals 3 cotangent 3x. Okay, 3 cotangent 3x. All right, as soon as it's cotangent, as soon as you know that it's going to be cotangent, then start with an asymptote, count 4 dots in, and then switch back. Oops. Okay, there's the graph, and then my last asymptote. Okay, and then label the period for this. So if we work out our period will be 2 pi divided by b, so 2 pi divided by 3. So my period ends at 2/3 pi, which means 1/3 pi. And I've got 3 asymptotes there. So those are the 3 I can use for my domain. So my domain will be all real numbers except 0 pi, 1/3 pi, 2/3 pi, etc. All right, the last part of cotangent is the way it's drawn. It's going to look like tangent. Regular cotangent, excuse me, yeah, let's make it 3. So I'm going to count 2, 4. So I just changed my scale. This is what cotangent looks like. What does cotangent look like to you? What kind of tangent? A reflected tangent. Doesn't cotangent look like a reflected tangent? This is regular for cotangent. It looks like this. So how do you tell the difference? If I gave you a graph and it looked like that, how would you tell if it's a reflected tangent or an actual cotangent? Where the asymptote is, exactly. All right, so even though it normally it resembles It's a look-alike to a reflected tangent. You just got to look at where the asymptote is. And then label your 3 probably on there would be helpful. And then your cotangent graph looks like this. So get a couple of those cycles on there. The range of this is still negative infinity to infinity, or all real numbers. All right, any questions about that?